Good morning to everyone. In today's video, we are going to see the star delta connections. So already we seen our first unit, that means in the DC circuits, the interconnections of the elements in form of series and parallel. Series and parallel. There I just say what is mean by series and what is mean by parallel means if the element if two or more elements connected in series, the current in the first element is same as to the current in the second element for the series. Or otherwise, the end terminal or negative terminal of the first element is same as the starting terminal, that is positive terminal of your second element. So ending terminal of your first element is same as to the starting terminal of your second element for your series. Whereas coming to the parallel, if the elements are connected in parallel, the voltage across the first element, is same as the voltage across your second element, or in other words, the positive terminals of the two elements are same, as well as the negative terminals of the two elements are same, because I'm just redrawn this element. So by making only single positive node as well as single negative node, this is for series and parallel. Likewise, if I go for the number of resistors, if I increase the value number of resistors, I just be connecting like this. Okay, just kindly excuse. Right now, apart of this series and parallel, we have another format of interconnections, that is star and delta connections. So here we will see how what is meant by the star and how it is really connected, the elements are connected, and how the resistances or how the equivalent values of the resistance will be divided across these terminals we are going to see. So in the starting, as per the first transformation technique, the first transformation technique we are going to see for the delta to star. So here first I am going to see what is say about what is meant by the star and what is meant by this delta. So here the star means the resistors. So right now I'm talking with respect to the resistors. The same can be extended for the inductors and capacitors also. There is no issue. If the elements are connected, in the form of alphabetical Y format, or in other words, there should be a common terminal. That means you may connected all the negative terminals of the resistors, or you may connected all the positive terminals of the resistors. Either way, you are going to be considered as star connection, either in this way or this way. These two will be comes under the star connection. So either you may connected all the negative terminals, or you may connected all the positive terminals. Okay, so this is star. Here in this star connection, there is a possibility of grounding. There is a terminal for grounding. Okay, this is the advantage of star compared to your delta connection. Then what is mean by delta? Okay, what is mean by delta, how it will be connected? In delta connections, similar to your series connection, all the terminals will be connected. Okay, the ending terminal of your first element will be the same as your starting terminal of the next element. Likewise, it will be closed. Either you may consider it like this or you may consider like this. It will be called it as delta connections. Okay, delta connections. Here I am just considering the resistance, but the way of representing these three resistors, in terms of your, with the terminals 1, 2, 3, 1, 2, 3. So here from 0th, I mean that means from neutral to your 1, I having only one resistor, I consider it as an R1. Similar fashion here it is an R2, and similar fashion from 0 to 3 it is in a single resistor, that is R3. And likewise, if I am considering this terminal 1, this is one node number 1 and 2, between these two nodes I am having one resistor, that is R12. It will be given in terms of R12. Likewise, between 2 and 3 it is R23, and between 1 and 3 it is R31. So the equal resistance between your nodes, it will be given with the value R12, R23 and R31. It will be connected between 0 to 1, so it is given as R1, R2 and R3. So I hope it is clear for you how this for delta R12 is coming. Between the nodes 1 and 2, the resistance value is 1 and 2, R12. Okay, the same thing is represented here. Considering the three resistors R1, R2 and R31 is connected in delta. Okay, delta. So this delta we are just want to transform into the star. So here between this node 1 and 0 I am just connecting the R1, and 3 to 0 I am just connecting R3, and likewise. So now I just want to know what is the value. Okay, what is the value of this R12? What is the value of this R12 in terms of star? So right now we are going to see what is the value between the, okay, what is the R equivalent between your star. Okay, R12. What is the R equivalent resistance? Between your R12? Okay, between R1 and R2. So I just want to see the R equivalent resistance. Here if you observe this, for this delta connections, I am only concentrating this node 1 and node 2. Okay, between this node 1 and node 2 I am concentrating node 1 and node 2. But what about your rest of the element? Sorry. What about your rest of the elements? That means this node will be the common. Anyhow, these are in, I mean, I am not talking about these three elements right now. I am talking with these two elements itself. How these two elements are connected? These two elements are connected in series. That means, can I redraw this one like this? These two elements, that means these two elements are connected in series, and that portion is in parallel with my 1 and 2 node. So what is the value of these two things? R31 and R23. So this value is R12. So can I say this, the R equivalent, okay, the R equivalent for this R12, okay, between your node 1 and node 2, the R equivalent in form of delta is nothing but R12 is in parallel with R31 plus R23, because right now I am concentrating only these two terminals. Okay, I am concentrating these two terminals. At that time, these two resistors are in series, which is in parallel with my R12. So I can give it as an R12 is parallel with R31 plus R23. Okay, so this is in delta. What about your star? I am just seeing between node 1 and node 2. At that time, this node 3 is in open condition. When it is in open, the current flowing through that element is 0, definitely the voltage is 0. So I'm no need to consider this element, which is we call it as a reductant element in our electrical terminology. So I'm just eliminating. So the rest of the elements are only having R1 and R2. So the R equivalent in star will be R1 plus R2. The same thing we represented here. Kindly go through it once. So here we are right now considering the across the terminals 1 and 2. So when I redraw this element, R12 is in parallel with the combination of R31 and R23. So when I simplify this one, okay, we know that parallel equations, R1 parallel with R2, this entire term I am considering as a single element, R1 R2 divided by R1 plus R2. Same wise we written this. So this is for 1 and 2 terminals. When go for the star, only these two elements will be considered. This will be your reductant element. So R1 plus R2. So the effective resistance across your 1 and 2 terminals, is nothing but R1 plus R2. R1 plus R2 is equals to R12 in parallel with R31 plus R23 divided by this total summation, that is R12 plus R23 plus R31. Similar fashion, right now we just seen for 1 and 2 terminals. Likewise, if I go for 2 and 3 terminals, these two are in series, which is in parallel with R23. And right now if I go for this 2 3, this 2 and 3 are in series. So I can write this direct equations. Anyhow, for explanation purpose, I'm just, so this is star 2 plus 3, and right now here R23 is in parallel with R31 plus R12. So divided by R12 plus R23 plus R31. Likewise, when I go for 3 and 1 terminals, R1 plus R3. So can I write this one as R12 plus R23 plus R31. So right now I get the set of equations in terms of star. That means R1, R2, R3 are the star resistance, and R12, R12, 2, 3 and 3, 1 are the delta equations, delta resistors. So right now I can get the values in terms of star and delta. So if I'm this is my equation number 1. If I'm assuming this is my equation number 1, 2, 3, 2, 3. So to get R1, so right now I'm only interested about R1. If I want to get R1 itself, okay, if you I want R1 itself, if I'm considering the equation number 1, okay, if I'm considering the equation number 1, subtracting with equation number 2, and again adding the equation number 3, the resultant value, right now we will check for the LHS first. R1 plus R2 minus R2 minus R3 plus R1 plus R1 plus R3. So right now R2 R2 will be cancelled over, R3 will be cancelled over, the leftover LHS term is 2R1. So similar fashion, if you solve this right hand side also, you can get the equation. So if you rearrange the terms, you can able to get the what is the resistor R1 value in terms of your delta delta resistors. There you can able to find out what will be the values here. So I'm just go through my notes once. So similar fashion, I am just considering the terminals. Previously till now up to here we considered for the 1 and 2 terminals. Later we go for the 2 and 3 terminals, and later at 3 and 1 terminals. So we get the our final expressions. So I just sum here. So the equivalent resistance between the 2 points in the delta connections should be equals to the equivalent resistance between your star connections. So the same thing we represented R1 plus R2, the expressions. Okay, so here the same thing we performed. We just subtracting the first two equations to get your expression in terms of R1 and R3. Later we add up those values and find out what is the R1 expression in terms of your delta resistors. Okay, delta resistor. This is the R1 in terms of your delta resistors. Similar fashion, if you solve for the rest of the elements, if you try to solve for the rest of the elements, these are the values you are getting for R2 and R3. That means right now, if you know the if you know your delta values, if you know your delta resistors, I can be able to find out what will be the resistance values in the star. Okay, so this is your delta to star conversions. So if I know the delta values, I can be able to convert into the star. So this is the thing. The same thing if it isn't vice versa. That means I know the star values, that means I know the values of R1, R2 and R3 values. If I want to find out what will be the R12, R23 and R31, how to we perform? So already you know the R1 value, that means the resistor values, star resistor values in terms, what is the R1 value in terms of delta? Already here you have these values. So take those values and multiply. So multiply R12, R23 and R31. Okay, so once you multiply these values and sum up. So if you multiply these values, that means R1, R2 plus, when I go for this, so when I multiply this R1, R2, add up with R2, R3 and R3, R1. So now I get all the equations. So try to divide this value. If I divide this value, how I can get? Because the denominator values are all the denominator values are same. So if I take the common term on right hand side, that is R12 plus R23 plus R31 whole square. And here if I multiplied and each and every term will be repeated, because here 1 2 is there, 3 1, here 1 2 is there, 2 3 is there, 3 1 2 3. So every term will be having one square value, because I am just multiplying 1 and 2. In 1 and 2 I have R12 and R12, so it will be the square. So, and the rest of the elements, 2 3 is here and 3 1 is here. That means if I take the common on the numerators, or you may check from here. So here if I multiply R1, which is here, that will be the square, 2 3, that is the square here, that is 3 1 here, that is the square. The rest of the elements are common. So if I take out the common value of R1, R23 and R31, the rest of the values will be R12 plus R23 plus R32. So kindly check here. So if I take it common, the rest of the things is R12 plus R23 plus R31. So from this, if I cancel over this, so this square term will be cancelled over here. So the rest of the element will be R1, R2 plus R23, R2 into R3 plus R3 into R1 equals to this value. Right now I am interested only with R12, because I need the delta value. So try to replace this R1 value Okay, try to replace this R1 value with R12 R31 divided by R12 plus R23 plus R31. So here, so whatever the rest of the element R12 and R13, if I replace this one with R1, the seventh equation will be appears as R23 into R1. So here I am rearranging, I'm just modifying this term with star resistor. So this is the thing. So right now R23 equals to the sum of, the product of individual resistors, and its summation, the summation divided by the opposite resistance. Okay, the combination, entire combination R1 R2 plus R2 R3 plus R3 R1. Okay, so that will be common for each and every resistor. If I go for the R23 resistors, so once again, okay, here it is. Okay, so if I go for the R23 resistors, that means between the terminals R2 and 3, the opposite resistance is R1, so I can go for R1. Further, if I go for whatever this 1 and 2, the denominator will be varied with R3. Likewise. So you can go through this. Okay, so denominator I just cancel over. Similar fashion, if you want to R2, you just replace the value with respect to R2 and you can get. Similar fashion, you can get the R23, R31 and R12 values. So from, if you know your star values, that means if you know your R1, R2 and R3 values, you can able to find out your R12, R23 and R31. So if you know the star, you can able to find out your delta values. So this is your star and delta transformations. Hope you can able to understand. In next classes we are going to see our numericals. Thank you.